Okay, so this is Chapter 11, Section 4, uh, volumes of prisms and cylinders. It's really one equation, but two parts of one equation. And the volume is the space within a three-dimensional shape or solid. One thing that you got to know about the units of a cylinder or the units of the volume of prisms and cylinders is that the units are always cubed. So inches cubed, feet cubed, meters cubed, these all pertain to volume. Uh, we've been doing surface areas. Those units are always squared. And then when you talk about perimeter, those units are not squared or cubed. It's just feet, inches, or meters. The area, or volume rather, of a prism is the area of the base times the height. Recall that the base are always opposites. They're never going to touch. They're parallel. The bases are always perpendicular to the height. So here's our height right here, h. It's perpendicular to both the bases at the bottom and at the top. And the volume of a prism, is going to be area of the base, and it's going to be uppercase B times the height, and that's the height of the prism. So the example that they have here, we have a rectangular prism, and it's a rectangular prism because the bases are rectangles. For this rectangular prism, we have since it's a rectangle, to find the area of the base, it's going to be length times width. So the length of this rectangular prism is 5. The width of this rectangular prism is 3. And then the height of the prism is 4. So when we find the volume of this rectangular prism, it's going to be 5 times 3 times 4, which is 12 times 5. So it's going to be 60, and it's going to be 60 feet cubed. So volume is area of the base times the height. Since it's a rectangle, it's going to be length times width, which is the area of that base. So length is 5, width is 3, height is 4. So the equation will be 5 times 3 times 4, which is 60. And since it's volume, the units are going to be cubed. It's 60 feet cubed. When we talk about triangular prisms, the base is a triangle, and a couple of things are going on. There's like two bases and two heights. So volume of a triangular prism, it's the same thing, area of the base times the height. But the equation for this base, since it's a triangle, is 1/2 the base times the height. Notice that we have two different bases. We have a lowercase b and a uppercase b. The uppercase b refers to the base of the cylinder. The lowercase b refers to the base of the triangle. Uppercase B is the area of the base of the cylinder, which is a triangle, and the lowercase b is the base of the specific triangle. Both of these heights are different as well. This height deals with the height of the cylinder. In this case, it's 5 because it connects to the two triangles. This other height is the height of the triangle itself. And in this case, the height of the triangle is 10. So we have, for the base, what I'm going to do is I'm going to change the color. When we have the equation for the base of the triangle is 10, and the height of the triangle is 6, whereas the height of the cylinder itself is 5. So when we do this equation, it's going to be 1/2 the base of the triangle, which is 10, times the height of the triangle, which is 6, times the height of the cylinder, not cylinder, height of the prism, which is 5. So that's going to be 6 times 5, which is 30, 30 times 10, which is 300, and 300 divided by 2, which is 150. And it's going to be 150 meters cubed. So, area of the base times the height, where the formula for the base is triangle, which is 1/2 base times height. Lowercase b refers to the base of the triangle. This h in blue refers to the h of the triangle, while the h in red refers to the h of the prism. So we just fill everything in. 1/2, 10 times 6 times 5, which gives you 150 meters cubed. That's the area for a volume, rather, for a triangular prism. And then we have a cylinder, and volume of cylinders. And the volume of a cylinder is also area of the base times the height. But since we're talking about cylinders, the base is a circle. And since the base is a circle, then we use the equation pi r squared. So for cylinders, the equation is volume equals base times height, but we can also say volume equals pi r squared times the height. And that will give us the volume for a cylinder. Remember that the height is perpendicular to both the bases. Since the bases are circles, this height would be perpendicular to both. And the area of a circle is pi r squared. So for this one that they give us, we have an oblique cylinder. It has a diameter of 2, which means we have a radius of 1. Remember that the radius is half of the diameter. We have a height of 3. So we'll use the equation, area of the base is volume equals area of the base times the height. We're going to substitute that with pi r squared, so base times the height, but we'll use pi r squared times the height. We're going to substitute 1 for the radius, and we're going to substitute 3 for the height. 1 squared is 1, 1 times 3 is 3. So our volume is 3 pi, and it's going to be 3 pi meters squared. Cubed, we're dealing with volume. 3 pi meter cubed. Okay, so we have volume equals base times the height, but since the base is a circle, we use the area of a circle equation, which is pi r squared. We have a radius of 1, we substitute it for r. We have a height of 3, we substitute it for h. So it's going to be pi times 1 squared times 3. 1 squared is 1, 1 times 3 is 3. And we get 3 pi meters cubed. Alright. So lastly, we have something called composite space figures. And what that is that it's a complex. We have a three-dimensional figure that is made up of smaller or simpler volumes, and we have to add those volumes or subtract to get the overall net volume of a particular figure. So in this case, they give you some type of aquarium, and it's comprised of a prism, rectangular prism, and it's comprised of a semi-cylinder or half of a cylinder. We know that the volume of a rectangular prism is base times the height, area to base times the height. In this case, it's going to be 36 times 24 times 24. We have a semi-cylinder, which is half of a cylinder. So the equation is going to be 1/2 the base times the height, since it's a half cylinder, which is 1/2 pi r squared times the height, which gives you this number. And then just to find out what they are together, we just add them up to get our net answer. So similar to what we just saw, we have a lunch pail which has two volumes. We have the volume of the prism, and we have the volume of the cylinder. And we're going to add them to get our composite or a volume. In some instances, you can also subtract, like there's a hole, a cylinder hole within a cube or something. We already know what the volume of a prism is. So volume of the prism, put P for prism, is base times the height. Since it's a rectangular prism, it's going to be length times width times the height. They give me a length of 10, a width of 6, and a height of 6. So it's going to be 10 times 6 times 6, which is 360. That is the volume of the prism. Volume of the cylinder is also the base times the height, but it's a semi-cylinder, so it's going to be 1/2. So it's going to be 1/2 pi r squared times the height. We have a radius based off the picture of 3, and remember the height connects the two circles together, in this case semicircles, so it's going to be this semicircle and this semicircle. So the height's going to be 10 because the 10 connects the two. So the height is going to be 10. So that gives us 1/2 pi 1/2 pi 3 squared times 10, which is going to be 90 times 90 divided by 2, which is going to be 45 pi. They want us to round it to the nearest cubic feet, so it's not going to be in terms of pi, so 45 pi is approximately 141. So we have the volume of the cylinder, we have the volume of the semi-cylinder, and we have the volume of the prism. So we're going to add those two guys up, the volume of the prism plus the volume of the semi-cylinder, which is going to be 360 plus 141, which gives me a composite volume of 501. And it's going to be 501 inches cubed. 501 inches cubed. So we had two volumes, the volume of the cylinder and the volume of the semi-cylinder. We got the volume of the prism as length times width times height, which is 10 times 6 times 6, which gives me an overall volume of 360. We did the volume of the semi-cylinder as 1/2 base times height, which is 1/2 pi r squared times the height, which gave us a volume of 141. and we just added those two guys together to get 501 inches cubed. Alright, this is section 11.4. I hope you guys have a great rest of your day.